Okay, so today we will be starting with the session 12th of Machine Learning Bootcamp. And in this session, we will be getting with unsupervised learning. And to be more specific, we will be seeing dimensionality reduction. Okay, so this is a major concern in machine learning. So what happens in the case of ML? So when you try to explore features, okay, so is my screen visible? The whiteboard, is it visible to you all? Okay, great. So what happens is, suppose I want to predict the price of house. Okay, so I want to predict the price of the house. Okay, so what I will be doing is I will be giving you the features. Okay, suppose I have feature M1, M2, M3, M4, and M5. Okay, so I have 5 features and I want to predict the price of the house at the end. Okay, so let it be, मतलब मैं कोई भी algorithm लगाऊँ. Let me be apply any algorithms to this. Okay, let it be supervised or unsupervised or any kind of algorithm. So what happens is, as I'm increasing the number of parameters, means of course, as I'm increasing the number of features, so my accuracy will be getting increased obviously. So in the first case, my accuracy is increased. In the third case, also my accuracy is getting increased. In the fourth case, my accuracy is somewhat increased, but after some point of time, your accuracy gets saturated and it starts getting decreased. Okay, so for the case of M6 features, my accuracy is getting decreased. So what does this represent? Of course, your feature means your number of dimensions. Okay, what does your features represent? Feature represents your number of dimensions. Suppose you have 2 features. 2 features means your data is into 2 dimensions. If you have 4 features, it means you have data set into 4 dimensions. But in that similar in the case of house price predictions, suppose you have 10 features. Okay, so it is into 10 dimensions, but it is very hard to visualize into 10 dimensions. Okay, so this was the major concern. The second concern was that as I'm increasing the number of features, after some point of time, my accuracy is getting decreased. Okay, so what will be the major reason that my accuracy is getting decreased? So there were 2 terms called, as the starting we have studied. One was underfitting and second one was overfitting. Underfitting means the model is too simple, means I have very less number of features to predict. So I want to predict the price of house, and suppose I want an minimum features of 4 to predict the price of house, but I have only 2 features. In that case, what will be happening? My model will be underfitting. Underfitting means my model will be not able to predict the correct price of house, means it is going underfitted. The second case is that I have minimum 4 features and I also have 4 features, means I'm able to predict somewhat reasonable price of house. Okay, so this is a good choice. The last choice is that my minimum features required is 4, but I'm having 14 features. So what happens in this case? I have too many features. So model starts to overfit. Overfits means in the starting we have seen we create 2 data sets. One is called as a training data set and one is called as a testing data set. We train our model on the training data set and test on the testing data set. So what happens is, when we have 14 features, the training data set gets learned too much features. मतलब वो रट्टा मार लेता है इन short features को. The features are getting by heart by the training models. And when I'm showing a new feature, when I'm getting a new features to the testing data set, it is not able to generalize. Means it is not able to predict. So you can understand from this diagram. Okay, so I want minimum 4 features for this house price prediction, but I have 2 features. So my model is underfitted. In the case of 4 features, my model is perfectly getting fitted. But as soon as I am increasing the features, my model is getting overfitted. Means it is getting, the features are getting learned by heart. So it is not able to generalize into a proper way. Okay, so are the concepts clear till now? What is underfitting? What is overfitting? इधर तक समझा क्या सबको?
And one thing to add, the example that I liked the most about underfitting and overfitting was this. Suppose you are trying to kill a mosquito with a bazooka. This is called the overfitting. And suppose if you are trying to kill a Godzilla with a fly hitter, then that's called the underfitting.
Okay. Till now everything is clear, so we'll be moving forward. Okay. So So the next thing came into existence is called as somewhat PCA. So why we need the use of PCA? Okay, so PCA is a dimensionality reduction technique. As we have seen that as we are increasing the number of dimensions, or accuracy is getting decreased after some point of time, and it is very hard to visualize in higher dimensions. So PCA is a dimensionality reduction. We are reducing the dimensions from 10D to 2D or from 40D to 20D. Okay, by transforming large variables into smaller ones, and we are taking care that the most of our information is retained. Means first our model was getting 98% accuracy. Okay, first of all our model was containing 98% of the data. Now after reducing the so it was in the case of 10 dimensions. In that case of 10 dimensions, our model was receiving 98% of the information. But as I'm reducing it to the third dimension or 2 dimensions, of course some information will be lost, but the information that will be lost will be very small. Means it will be somewhat about 4%. So at last, after 3, as I'm visualizing into 3D, I will be getting 94% of my data stored. Means it is not getting destroyed. Only 4% of my data is getting destroyed. So it is a good trade-off to choose between a 94%, since we are very much able to visualize our data into the 3D and our model is not getting overfitted. So that's why we use principal component analysis. So the question might arise, why we need PCA? So as we have seen, we have the problem of overfitting. The model gets learned by its heart, so it is not able to generalize. Okay, the model is not able to generalize. Okay. To reduce this approach, PCA reduce the overfitting problem. And what does PCA do? Is just remember the fact that PCA converts your high dimensionality data into low dimensionality. And what this dimensionality means, the number of features in your data set is directly proportional to the number of dimensions. Suppose you have 40 features in your data sets, means your data is into the 40 dimensions. If you have 2 features, means you are living into 2 dimensions. Okay, and what's the main goal? Okay, what's the main goal of your PCA algorithm is to reduce your 10-dimensional any dimensional data into lower dimensional. Means it is your higher dimensional data, and now it's reducing into lower dimensional. And why we are reducing it? We are reducing because we want to overcome the problem of, first of all, overfitting. The foremost point, overfitting. This was the main point. We want to overcome the problem of overfitting. Second, we are not able to visualize our data beyond 3D. Of course, in human eye, you can't visualize about 3D. So that's why the second reason is you can't visualize over 3D. Therefore, you want to reduce the dimensions of your features. Okay. Till now, everything clear. मतलब क्यों use करते? Why there was a need of PCA? Rest of the part will be full of mathematical calculation and statistics. But till now, why we need to use PCA and what's problem are getting overcome by using PCA? इतना clear है क्या? Yes. Okay, Samiksha has spotted. Okay, great. So now what does PCA does? This is an example of PCA. Okay. Suppose we have 3-dimensional data. So this is our 3-dimensional data. And what we are doing is we are converting it to low dimension. Okay, so we can see that it's a 2-dimensional data and we can easily visualize. And suppose if I want to classify the data, I can easily use my different algorithms. Means if the data is unlabeled and CNN, so I can clearly separate out the blobs. Okay, I'm clearly able to predict the blobs. Okay, but in the case of this, it was too difficult for me to select the categories. Okay, so now we'll be moving on to the steps of PCA. Okay, so yes, okay. So now we'll be diving some statistical concept. Don't worry if you don't get the statistical concept. Just make sure you understand what does PCA does and why we need to use PCA. If you get the concepts, it's well and good. Okay. Okay, so now we'll be starting with some of the statistics concepts. So each data in nature, or you say 90% of your data, most of your data lies in the case of Gaussian distribution. Okay, it's called as Gaussian distribution. what does Gaussian distribution means? Gaussian distribution means your data will lie at the मतलब तुम्हारा data just take example of your first year students. Okay, first year students, or let's say the age group between 18 to 20. So what do we expect between the height of the person between the age group of 18 to 20? So it will be ranging from 160 centimeters to 180 centimeters, right? Most of the cases, I am saying 90 or 85% of the cases of those who are of the age 20 have have heights of in the range between 160 centimeters to 180 centimeters. Do you all agree? Except a few exceptions. Yes. Okay. So होता क्या है कि in the real nature problems or real world problems, suppose I am taking any case. Okay, so यही case ले लेते हैं. Just take the case of your height. Okay, so what we were doing in the case of height, we know the people of age group 20, the people of age group 20 have the height ranges between 160 centimeter to 180 centimeter. 70% of the chances are there. Okay, so what does this represent? Suppose this is my 160 and this is my scale of 180. So most of the students have the average height of near about 170. So what is the 170? 170 is called as the average. You can call it as the average. The second term for average is called as mean. Okay, the second term for average is mean. So what does this signify? This is called as your Gaussian distribution. Gaussian distribution means your any set of data rise into the particular range, and the range has an average, and the average is called as the mean. Suppose in the case of our age group, the median age, I'm not taking about the exact, but the mean age is about somewhat 170. Mean height is about 170 centimeters. Okay, so this was mean. Means your average. And for your average formula, what's the average formula? Xi plus x2 till xn divided by number of points. Okay, so that was the formula for your mean. Now what happens is you have second term called as you got the term mean. So this was your mean. Mean was your x1 plus x2 till xn divided by n, and the second term which will be what does variance signifies and what does variance means? Variance means how far my points are being spread. How far are my points being spread? In this case, our points are spread in the range of 160 till 180. Okay, so this is variance. Simply means variance. Anyone asks you what does variance signifies? You just tell them variance tell the spread of the data. How much my data is spread from the mean value. And what does mean means? Mean means your average of the data points. Okay. Again, I will be repeating. There's a Gaussian distribution. Gaussian distribution means your data lies into the particular range. You take the average, and the average comes out to be any point, and the average you call the average as mean. The second term for average is mean. And how do you take the average? You take the summation of all the points divided by total number of points. So this was your mean. And now what's the variance? So once you have find out your mean point, okay, the next thing is variance. Variance means how far my points are from my mean. It's called as my variance. In simple words, it's called as a spread. How far my points are being spread. Okay.
And can anyone answer what should be the y label of this graph?
Yes, anyone? इधर तक को भी समझा क्या? What is mean and what is variance and what is Gaussian distribution? Till now, everything is clear. If you are in doubt, just ask.
Yep, that is frequency. number of boys.
Okay, great. Okay, so you have done with the concepts of mean and variance. Next thing, what we'll be seeing is called as a covariance. Covariance. What does covariance signifies? Suppose I have two features, namely x and y. I have two features, namely x and y. What does the covariance signifies? If the covariance, there are two conditions. One is the covariance is positive, and second, the covariance is negative. What does positive covariance signifies is that if my x is increasing, my y will also be increasing. And if my x is decreasing, my y will be increasing. In the case of positive covariance, they are directly proportional to each other. Since my experience is increasing, you can imagine that since my experience is increasing, my salary will be also getting increased. Okay. And in the case of negative covariance means as your age is increasing, the number of years you will live is obviously decreasing. Okay. So just keep into the mind that you have to covariance. What is covariance? Covariance tells a relationship between two variables. And what does this covariance signify? If your positive covariance means if my x is increasing, my y will also be increasing. And if my x is decreasing, my y will be increasing. Okay. So these were the basic statistics terms you need to understand. And now we are back to our PCA. Okay. So the main aim of the PCA. So the first step in the PCA lies is that you have to standardize the data, and we have seen that for standardizing, what we can do is, and yes, the last term is called as the standard deviation. Okay, so I forgot to mention standard deviation. Standard deviation means how far are my points from my mean. Your variance was your spread. Okay, the total spread, and your standard deviation signifies this is my particular point. How far is that particular point from my mean? Okay, so that's what's your standard deviation. Now, what you will do is once you have got your data set. Okay, suppose your data set has two columns, your x and y. So what you will be doing is you will be taking each value of x and you will be subtracting the mean. Mean means the average. You will taking the whole average of the x column. And suppose your first value is something 18 and the mean comes out to be 4 and your standard deviation is 2. So 18 minus 4, 14 by 2. So now this current Z value will be getting substituted into the first row. Okay. So we have done the first step, that is standardization. The second step on this, it's called as the covariance matrix. Okay. So as I already told you, the aim of the covariance is to see is there any relationship between the x and the y variable in our case. Okay. Sometimes they are highly correlated and they contain informations. And to compute the covariance, we generally use a covariance matrix. Okay, suppose you have three columns, x, y, and z. So first you will be computing with x and x. Second you will be computing. The diagonal is always the same, x, x, y, y, z, z. And you have studied this is called as your symmetrical triangular. So this is almost symmetry. This is lower right and upper right. Your values, these are almost symmetric. So how do you calculate the covariance? Okay, so we have studied the formula for mean. What was your mean? Mean was your xi plus x1 plus x2 till xn divided by your n. N represents your number of observations. And the formula for your variance. So where is my mouse here? Okay, the formula for your variance was something like 1 by n. N represents your number of observation. Summation I ranges from 1 to n of xi. Xi means your this value or this value. Xi minus mu. Mu you are already calculated from the above step B. Okay, so this gives your variance. And what does covariance signifies? Covariance signifies is the two variables related or not. If they are related, in which sense they are related, if they are positive correlated or negative correlated. Okay. So your so the formula for covariance is xi means your current value minus x mean of x. So we already calculated the mean of x, that is 1.81, multiplied by yi, this is your yi, subtracted by mean of y, divided by total observations minus 1. Make sure to note that it is n minus 1. In the case of variance, it was only n. So just take the example of your covariance. We have seen that we have to calculate the covariance of x, y, xz. So we will be first calculating the covariance of xx. So we take the first values 2.5 and 0.5. Next, what we will be doing is x minus x bar. So we'll be subtracting 2.5. And what was our x bar? X bar was this 1.8. Okay, in the case of 0.5, second case minus 1.8, and this gives you these values. Okay, and after that you are multiplying x minus x bar into again x minus x bar, since you are converting the covariance of xx. Okay, and at last you are summing up and putting into the formula. So I have summed up these two variables. I'm finding the relationship between the first and second. So I found out the sum is 1. Just substitute here. The sum was around 5.5 divided by n minus 1. Here n was our 10. 10 minus 1 is your 9. And so I have shown you the step 5.5 divided by n minus 1. That is 5.5 divided by 9. And that gives the covariance of xx matrix, that is 0.61. Similarly, you can calculate for your yy. Now we will be seeing xy, covariance for xy matrix. I am again telling you, these all steps, no need to worry. Okay, so these are all defined in your sklearn library. For your understanding, I am telling you these steps. Okay, for your xy, I am taking these first two observations, 2.5 and 2.4 and 0.5 and 0.7. Against the x minus x mean, y minus y mean, and at last I'm calculating the sum of these values. And after calculating the sum, I'm dividing by n minus 1. Okay, so once I have done for my xx, of course, this will be my xx matrix for two variables, and here will be xy, here will be yx, and again here will be yy. Okay, so I have substituted my values here. Okay, my values. So I have told you to study about eigenvalues and eigenvectors. So what does eigenvalue? How do you find this? It is called as A minus lambda I is equals to 0, where I is your identity matrix and A is your covariance matrix. So eigenvectors and eigenvalues are the linear algebra concepts that we need to compute for the covariance matrix. Okay. So once we have calculated our covariance matrix, we are substituting here, and we are calculating here the eigenvalues and eigenvectors of all these. Samiksha is asking why my n minus 1 is considered for covariance. Suppose any negative value comes, so we use n minus 1 for the bias term. Okay, so this is for our bias. Okay, suppose someone substituted bias means you don't want your values to be getting too large or too small. Okay, so that's why we generally use n minus 1 in the case of covariance. Okay, so now we'll be using the eigenvalues and eigenvectors. So for calculating the eigenvalues, our formula is A was your covariance matrix minus lambda. So this was your lambda. Here I is your identity matrix. Now we'll be finding the eigenvalues and eigenvectors. Okay, so before finding the eigenvalues and eigenvectors, the PCA, we are seeing that PCA stands for principal component analysis. So what does principal component represents here? Principal components are the new variables. So we will be generating new variables that are constructed from the linear combinations or the mixture of the initial variables. Earlier we were having 10 variables. Okay, so 10 different variables in this case. And now I'm generating 10 new variables using the combinations of these 10 variables. Suppose I'm using 1 and 4 features, third and 6 features. I'm generating 10 new features. Okay, and I'm taking care that these all are uncorrelated. Okay, and the most of the information lie within the first component. Okay, so don't need to worry about it. And after calculating the eigenvectors, we are arranging them into the form of ascending values. Okay, okay. Just see the visualization. Okay, so PCR constructed such that the first principal component have the largest possible variance. And what I have told you, my variance is the spread of the data. Okay, so here my, of course, my variance is less. Okay, okay, let me give you an example. Uh, so these are the two plots. This is a plot number 1, and this is my plot number 2. Uh, can anyone tell me whose variance is high and why is the variance high? Just remember the definition of variance. What was our variance? Variance was the spread of the data. Spread of data. Who is more scattered, so variance is high. And just tell me, is it good having a high variance or low variance? Is it good to have a high variance or low variance? Low variance कैसा होना चाहिए? ज़्यादा होना चाहिए, कम होना चाहिए? Low variance is good. Okay, great. But in but we are taking into account. Okay. What happens in the case of high variance? Just a little wrong. What happens in the case of high variance? You are capturing more and more information about the data set. Means you are able to get more and more information about the data set. In the case of PCA, so you will be choosing that subset, that value which is having a high variance. High variance means you are having a large number of information about the data set. Okay, suppose this value is having very low variance, so you don't have not much knowledge. Means your values were ranging from 168 till 175. So you have a very less variance. But in the case of bottom case, your values are ranging between 160 to 180. So your variance is obviously high. And what does high variance represents? Means more and more points are falling into this case. Okay. इधर तक समझा? Means you want to have a high variance. Okay. So the first principal component, just imagine that principal component is nothing but a line which has a high variance. Okay. And when is the high variance in the case of this diagram? So when my this axis, the axis which is rotating, is into the same direction as this my purple axis. Okay. Just notice here. So this axis will be having a high variance, means it is containing much and much information about the data set. In short, the MSE is very less when the axis is parallel to this. Just imagine. Are you getting what I'm trying to say? That my first principal component is nothing but a line, and my line should have a high variance. And why should it have a high variance? Because if it is having high variance, it will be having a high information. And why it is having a high information? Because high variance signifies your data is very much spread. And if your data is very much spread, your data will have a lot of information. Have you understood the chronology why I'm saying that high variance is necessary and how I'm calculating the PC1?
So just remember this high variance model will capture the most, in the case of PCI, will capture the most amount of data.
Okay, great. So means we will be seeing how to calculate the first principal component. But just remember, as we are taking the list into the ascending order, means your first principal component, your first PC1 will always be having high variance, and it should always have a high variance. The second PC2, the second principal component analysis 2 will have the low variance as compared to the first, and so on. Okay, so the eigenvectors of the covariance matrix are actually the directions of the axis where the most covariance lies. Okay, so don't worry about my theoretical part. So just remember the eigenvectors. In the case of your covariance matrix, you will be finding your eigenvectors. So this was so a minus lambda I, and you're finding the values of lambda. So once you have found out the values of lambda, it will be telling you the direction of the axis where the most of the variance lies. Most variance means most information. Okay, and after that you will be ranking your eigenvectors in the order of their eigenvalues. Suppose I have been for the eigenvector 1, eigenvector I will be representing eigenvector 1 as EV1 has a value of 4.2. The next eigenvector, since I'm sorting them into the ascending order, the second eigenvector will be having the value of 3.8, and the third eigenvector will be having the value as 2.7. So I'm uh, sorting them into the highest to lowest values. Okay, so first one is my always have the highest values. Okay, let's suppose our data is of two-dimensional data. Okay, so we have two-dimensional data and we have two variables x and y, and now we have calculated their eigenvectors. So I'll be not telling how to calculate the eigenvectors. I already told you that you should have a quick refresher about eigenvalues and eigenvectors. So we have calculated our eigenvectors, and similarly after that we have our eigenvalues. Okay, so we can see that the eigenvalue was for the first vector is much higher. It is 1.2, and the eigenvalue for the second eigenvector is 0.04. Means roughly it's account for, I'm not sure, but roughly it's account for a 90% of the variance. Means since my variance eigenvalue is high, my and I have only two variables to compare, I can clearly see that my this value as a high eigenvalue. And what does high eigenvalue represents? High eigenvalue represents high variance, and I want high variance in my first order. So we can see that this is having high variance, means this is having a lot of information, and this is having a very less information about the data set. So even if I drop this value, my accuracy will be almost same. First of all, my accuracy was something over 94.5. Now after dropping this column, my accuracy was about 94.2. But what was the advantage of dropping this column? Since I have dropped this column, my model is not getting overfitted the first case, and I'm now able to visualize my data, in a much clearer format. Okay, so after eigenvalues and eigenvectors, the next step we'll be seeing is called as a feature vector. And what does the feature vector represents? After computing your eigenvectors, suppose I have computed this eigenvector. So this is my eigenvector 1, this is my eigenvector 2. I'll be simply arranging them into the matrix format. Okay, so simply I have put my first, this was my first eigenvector, and this was my second eigenvector. Okay, now we choose whether to keep all these component or discard. As we have seen, the first eigenvector was having the eigenvalue of 1.28. The first eigenvector was having the value of 1.28, and the second eigenvector was having the value of 0.04. What does this signifies? क्या समझ रहा मतलब इससे मतलब? Since my eigenvalue is very high in the case of first eigenvector, my information that is written is very high, and in the case of second eigenvector, my value is 0.04. It is very tiny as compared to the first one. Means my information in the second variable, that is I'm using for prediction, is very less, so I can drop this value. So what is happening is, now it's up to me that should I drop it or not. So I came to a conclusion that it is not of any significant importance, so I'll be dropping this column since my eigenvalue is very less. After dropping this value, I'm calculating again the new matrix. I'm simply just taking this matrix and calculated this. Just replacing, and I'm dropping this column. Okay. Now after dropping this column, I have got a final matrix called as feature vector V. And what I will do is that I'll be taking the transpose of this feature vector. Okay. I'll be taking transpose and I have dimensions of m cross 1 in the case of this, and previously and I will be last step. What you will be doing is that after dropping the values which have less eigenvalue, after dropping the less eigenvalues, I'm calculating my feature vector, and I'll be doing the transpose of my feature vector. So this was my feature vector. Let me say it as feature vector T, and now feature vector is transformed to this only single column, and I am doing the transpose. And what will the transpose looking like? My columns will be rows will be getting converted into columns, and columns will be getting converted to rows. And this is my transpose. And what I'll be doing is the final data set is my feature vector transpose multiplied by the standardized original data set transpose. And we have already calculated the standardized data transpose from here. We have already made this table of x and y. So call it as Z. And now what I'm doing is I'm multiplying my feature vector transpose multiplied by Z vector transpose. I know this is a bit a somewhat difficult concept for someone or all of you, but just remember the fact. What were we doing? I will summarize it once again. Okay, just remember the fact. Okay, let me screen. Now I'll be asking you the questions and you have to reply me. Okay, so be prepared. Okay, why were we using PCA? Why were we using PCA? Give me 2 reasons. All this we have studied is just the mathematical part. You don't need to worry much about it. This was for your just understanding. Now my question is why we are using PCA? The need of PCA. We have just studied what was the need of PCA.
For first reason, we saw some 3 graphs. Can anyone remember what they were?
Let them answer, please.
Yeah.
Yes, Sonali is correct. Nakul is also correct. Nakul, for multidimensional, what do you mean by multidimensional? Shilpa is correct. Okay. The first reason was the overfitting, said by Sonali. Means you want to reduce your overfitting model. And the second reason was you have data into high dimension and you want to convert it to lower dimension. Why do you want to convert into lower dimension? Because it is very easy to visualize. Okay. So these were the 2 reasons. Itna clear hai kya? Till now, you understand what was the goal of PCA? Is it clear till now? Forgot about the mathematics and statistics. If this is clear, then your algorithm is clear. You are good to go with your coding part. Just understand this concept. PC is just used for the first part. Anyone asks you the interview, what is PC used for? You will just be able to say that first we are able to reduce the overfitting problem. The second, we are able to convert why we are using PCA to convert the higher dimensional data into low dimensional data set. And why we are doing is that because I'm not able to visualize it to the higher dimensional data set, I'm able to visualize it to low dimensional data set. Simple. Even after reducing some of the dimensions, dimension D, I'm able to get almost same accuracy. First of all, I was getting 94.8 accuracy. Now I'm able to get 95.1% accuracy. It is great. If you're dropping 10 columns and out of 50, columns, if you are dropping 40 columns and you are getting the accuracy from 95.8 to 95.1, it is great. You're good to go. You should drop the columns. Means your 10 columns will have the maximum amount of variance. And what does variance signifies? Your spread of data. Okay. बस इतना पता होना चाहिए कि किसी ने तुमको पूछा what do PCA stand for and what was the need for PCA. Okay, great. And for the mathematical parts, we are done nothing. We are just doing the standard. First, we are doing the standardization. We are doing the standardization. Second, we are calculating the mean. Third, we are calculating the covariance matrix. After the covariance matrix, I will be selecting those columns or those vectors which are having a high eigenvalue, and I'm sorting them into the highest to lowest value. Suppose I have 10 values, so I'll be ranging from 1 to dash 10. And I'm seeing that after a value of 4, my values are almost near about 0. So I'll be just picking up the value of 4. So I'm taking the 4 values. And since I'm taking the 4 values now will be gets substituted into feature vector column. So this is my feature vector. And at last, what I'm doing is I'm multiplying the feature vector transpose multiplied by your standardized the first standardized vector transpose. This is the mathematical part. Ignore it if you're not getting it. Just understand what was the need of PCA. Now we are doing PCA. Okay, great. Are we good with theory? And now we should move with practical part. Is it good to go? Any doubt still here? Is there any part you don't have understand? मतलब ऐसा कुछ part रह गया कि तुमको नहीं समझा? If you are getting of 100%, if you are able to grasp 40%, it is more than enough. You can study later onwards. Just be able to figure out what was the aim of PCA, what was the need for PCA, and why we are using PCA. If you are able to grasp these concepts, you are more clever than I. These were very tough concepts. Forgot about the mathematics. Okay. So Vishal, I am handing over to you. You are good to go with your part. Okay, coding. I will stop sharing this.
Everyone can see my desktop, right?
Yes, it's easy work.
Okay, and I'm in my command prompt.
Yes, yes, yes.
Okay. So first we'll go into ML Bootcamp. Then we'll open our Jupyter notebook as usual. Right, week 6, and we'll make a new notebook. Right, good. So the very first thing that we always do is to import the libraries. So our as usual libraries, import NumPy as NP, import pandas as PD, and I hate matplotlib, so we are going to use plotly. Plotly.express as px. And from last time, if you remember, then I imported this utility function from utils import set default. This sets the default configuration of plot because I want to make them pretty and compatible with this dark mode. Right? And for our implementation of PC algorithm, we'll need these libraries. Sklearn.model selection import printess split. This splits your initial dataset into training and testing part. Sklearn.neighbors. What's the spelling of neighbors? RS, I think. Right? What K nearest K neighbor may R classifier should be S here. Right. From sklearn dot decomposition import PCA. So whatever we learned in the theory part, all of that is implemented in this PCA class, right? And we are going to use a metric. It will be accuracy score. I hope that neighbor's spelling is right. Correct. The very first thing that I do is set the default configuration of plotting library. And then I am going to read the dataset. Right. So our as usual function pd.read_csv, and this time we are going to work with the previous dataset, that MNIST dataset, right? So if you remember, then in week 3 we saw this MNIST digit dataset. You can just click here and where is this? You can just view this as a raw and download it from there, right? So whatever I'm writing here, you can instead write that URL. This will fetch the data from there. For me, it's MNIST underscore digit dot CSV. And we are going to see the first 5 values so that we know that data is imported correctly. So we have already seen the first column level of the image, and the later 784 columns are the pixel values of the image, right? So you'd have the values ranging between 0 to 255. That would be pixel intensity. 0 would mean that your pixel is black, 255 would mean that your pixel is white, and anything in between would be a grayish mode. The very first thing that we'll do is split our x and y. This is a supervised learning problem, right? We want to classify the different digits given a picture. So data.ilog. We want all rows, and except first column, we want all. Like this. For y, we want the first we want the all rows, and we want the first column. And I'm going to write np.array in front here, because I want to convert the pandas data frame into an np and dimensional array. Check the shape that we have done all the things correct here. We are just going to see the shape of these x and y. X dot shape, there is no parentheses here. Y dot shape, and yeah, you'll have what's this? Almost 20,000 uh, rows examples, and you'd have 784 features. This 784 is 28 by 28. So your images are 28 by 28 grid, if you want. Your y is this label of the of different images. So this is also the same as the number of rows of x. So after this, we are going to see the first image. Uh, just visualize that the images that we have got are correct. So for doing this, we are going to create a figure, and we have imported the plotly as plotly.express as px. So we are going to use that px dot im show, and for this I'm going to give the I'm going to visualize the first image, right? The first row and all the columns. And I'm going to reshape it in their normal format, the grid type, 28 by 28. And we are going to set the color map. We have color continuous, color continue, scale equals to gray. And we are going to set the, we'll do just this, right? So your first image in the training data set, training not, the whole data set is this 5, right? And we are also going to see the label. So let's just make the title as this, update layout. We can give the plot title, plot x-axis title and y-axis title in this update layout, right? So we are going to just give the title as, and I'm going to write in this a funny way, right? This is a fast string. Okay. The label is in this curly braces. I can write anything. It would be the variable. So for this, I'm going to write the y of 0. But I want to make this more general. So I'm going to write index as 0. So I'm going to change the 0 as index here and here too. Alright, good. So the first one is 5, second one is 7, almost looks like a 7. The second one is 9, right? So the label and the image are these. Right. So after that, we are going to split the original dataset in training and testing part. So as usual, xtrain, xtest, ytrain, ytest, and we are going to use the train test split function. We are going to pass the x and y, and we are going to set the test size as 0.2. From all the original examples in your original dataset, you would have the 0.2 times the original samples reserved as testing size. Right? And I'm going to set the random state as 101. This is for reproducibility purposes. Right? And yeah, so here also check the extend shape and x shape, right? So from that almost 20,000 example, almost 20% of those are in X test, right? Because we wrote this 0.2, right? So the very first thing that we did in our week 3 was to use Canon Classifier to correctly recognize these to deal with our classification problem, right? So we are going to build that again, right? KNN equals to K neighbors classifier, and I'm going to give the random state as, oops, I'm going to fit this with X train and Y train. And after that, I will be predicting on train and test both. If I train it, Canon not predict underscore train and y underscore train. Similarly for test, TE is for test, above one TR is for train. Canon dot predict. I think I did something wrong. Underscore test. And after that, we are going to print the accuracy score. And again, I'm going to use that funny notation, the fast string. So the accuracy for train is accuracy score y underscore train and the prediction that you made y underscore train print. And the next thing for test, it's accuracy underscore and just like before, but this time for test. Y underscore test spread. Right. What we did. Okay, neighbors classify what's the spelling. And we'll just let it train. So can anyone remember what was the training for K-nearest neighbor classifier? How does a KNN classifier work? Does anyone remember? No one. Well, actually, it calculates the most what you can say the closest neighbor of that the testing data that you have kept them. So it is kind of a lazy algorithm that works on the test time. Its training is very simple. You just memorize all the data that you give. And I'm going to run this later on. But you can see that the training accuracy is 0.97 and for testing accuracy 0.95. That is really good, but we are learning PCS, so we are going to see that how we can like reduce or increase the accuracy. So the very first thing that we'll do is first calculate the time that this cell is required and that is this cell is requiring to run. So this magic command that I've wrote here is this person time it, and I've given the dash r as 3. This would mean that this cell has to run 3 times, and for every time this will loop only one time. So for the first time, then for every time the accuracy will be same. We just want to see that how much time that this cell requires to run. Right. And one last time. Yep. So this cell took almost 16.7 seconds and plus minus 343 milliseconds. So this is a very, what you can say, compute heavy implementation. Right. So we are going to see that how we can reduce this time required to run this cell. We have learned the PCS dimensionality reduction technique. We are going to use that. And for n underscore components, so Aditya has told you that we use it's up to us to decide that how many components we want in the output data set, right? So after the decomposition, how many columns you want, how many features you want. So for n underscore components, we can give anything we want. But if you give this between 0 and 1, this will this sklearn will uh, think of it as explained variance. So if you write this here 0.95, so this sklearn will think that you want a model that has enough number of features that will give me a 0.95 explained variance, right? I'm going to set the random state as 101 for reproducibility purposes. And you fit this with trained dataset. You never fit this with testing dataset or the whole dataset. You want your model to see only the training part. Right? After that, you are decomposing the training. PCA dot transform. You are giving this X train, and you are also giving this for X test. PCA dot transform X underscore test. Okay. This will decompose your data set and all the things that Aditya have told you, that like you have to do all this eigenvalues and eigenvectors thing and select all that different values of values and eigenvectors, and after that you have to multiply it with all your original g vector. All of that have been done with this PCA class, right? So yeah. Everything is clear till here now. We haven't done anything more than the basic stuff. Uh, ab- about till here, we have already seen in the week 3 part. We have done new things in this cell number 18. Right? Everything is clear up till now, right? Yeah. So we are also going to check the X-train shape. Remember the X-train shape earlier was this 15,999 and 784 features. Right? So after this X-train decomposed, we are going to see its shape also. We can see that the number of features have reduced from 784 to 153, and this still has the same, almost same variance of 0.95. Yep. And to get a sense of what this decomposition have done, we can again reproduce the original image from this decomposed vector. Right. So I'm just going to copy this above cell, Control A, Control C, and paste it here, setting the index as 0. I'm going to check the X as decomposed. Everything is same, and y underscore test. Yep. And the thing is that you don't have 784 columns anymore. So if you reshape it in 28 by 28, this won't work. So you have to inverse transform it. PCA dot inverse transform. From this 153 features, this will again get it back to 784 features. And this will work, right? So you can see that the image is kind of a blurry blob than before, but this still holds the same information and almost the same information, right? So after this, we are going to fit our k-nearest neighbor models in with this PCA, right? With this PCA decomposed data. So again, like before, I'm just going to copy Control A, Control C, Control A, and Control V. Right, guys, please don't judge me. This is the easiest way. I just have changed the your training data sets. I am going to write here decomposed, right? And after this, I'm going to predict on decomposed part only. I'm going to write the decomposed here also. Testing also, I'm going to write decomposed, also decomposed. And I need to change here also underscore D and underscore D, right? And we are going to run this. This will again run 3 times and you will get a similar output like this. But something will change. Can you guess what will change? What will change? Accuracy, test accuracy, or this the time required to run the cell? What do you think will change? Time, accuracy, or both? Right. So actually the time has decreased from 16.7 seconds to 11.9 seconds. And that this may be not true for the accuracy part, may be not true for all the dataset, but for this MNIST dataset, this is, I don't know why it's true, but it's true. Your training accuracy with decomposition is 0.9737, and without decomposition it's 0.9728. So weirdly, after decomposing your dataset, your training accuracy has increased just slightly. Earlier for testing dataset, it was 0.9585, and after decomposing, it's 0.961. So in this case, the decomposition part has come really handy into our use. Our test accuracy has increased by almost 0.01%. Right. So with this, you have done your PCA part. Any questions so far? Like, so are there any questions? I'm going to save this notebook. Okay. Okay. So
That's it
Aditya
from you,
Narwal.
sir.
Yep, we needed all these things only.
Okay, great. So yes, you can stop sharing the screen and now be ready for the surprise. Okay, so can anyone of you guess what is the surprise? What are we planning? Do you have any clue? Another food camp. Samisha, yes, we will definitely conducting our boot camp in further, but we are not planned it. Okay, so on what topic do you want the boot camp? The further boot camp. Any topic for the boot camp? In future, do you want something like bootcamp or an individual event on something like you want to study for CNN, so you want only the one lecture? Object detection and deep learning. Okay, Nakul, yes. Object detection and deep learning. Yes, I can teach that object detection. I have done my degree. Okay, yes, cool. In future, I will be definitely doing one object detection. I will be sending the mails for the same. Oh, so do you want a complete bootcamp of 5 to 6 lecture or just a one lecture for a particular session? Dipshika is saying, could you please open the feedback link again? Yesterday I told you that we will be opening the link for only the 12 till midnight. Okay, so is Atharva here? Atharva?
Yeah.
So can we open the link?
Yeah, okay, we'll see. Can you just DM me? We'll see what
Just
we do.
okay.
DM me on WhatsApp after this session. We just quickly winding this session by
Okay.
giving away the surprise.
So we'll be telling secret is that our team has been observing all the students from the past 6 weeks from the beginning of the lecture, and we came to a conclusion that some of you were the most enthusiastic students, the most engaging students. They were participating in all the lectures, replying to all our questions, has been interacting with Atharva and me, and many more has been participating in all the quizzes and everything. Okay, so we have selected 5 students and we will be giving some goodies or CS sets, CS swags. Okay, so can you guess who are those 5 names? In excitement. Five people we have selected for goodies. Okay. Khedkar, are you seeing the replies, Atharva?
One got it like really right.
Vishal, okay.
Come on, give me.
What about Aditya Daniel? Don't you wish Aditya should get the goodies or Atharva should get the goodies? Only Vishal. Okay. Okay, so okay, Sanskar. Great. Okay, so we will be revealing out the names of the 5 candidates one by one. So let's start with the first winner of this award. That goes to Nakul. Okay, so those who have said Nakul, Nakul is saying his name only. Okay, great. So Nakul was the first name on our list.
I think they are guessed correctly. Most of the students.
Yes. What will be the second name? Anyone? What is the second name on the list? Okay. Atharva, is your noise coming from your house? Or Vishal is
I'm getting that to maybe someone else.
uh,
Yeah, it was from participants. I muted.
okay. So the second one comes down to Samiksha. Okay, so I guess someone has said Samiksha, plus also said Samiksha, Sanskar and Samiksha. Okay,
Let's reveal the third name.
the third name is Sonali.
Okay.
Okay, the
Fourth.
fourth name. Any guesses for the fourth?
It's in the chat only.
Okay, so let's just reveal the fourth and fifth too.
Okay, Nafil has got it. The fourth is Daryl, and the fifth one goes to Chow.
So
Okay.
congrats guys, because you would be getting some CIS like CIS branded swags and some stickers that are from my side. I have a lots of collections of stickers and t-shirts. Like I like swags, so I have lots and lots of swags. So you would be getting some too from CIS. And Aditya, could you just explain further?
Okay, so for those who are outside India, so Daryl and Chow, we would try our best to deliver the swags, but we won't guarantee for you at this point of time right now. For those who are from India, we will try to shipping them to your swags directly to your home. Okay, so that's it from my side. Okay, so these were the 5 students.
So basically, these 5 students would be getting swags delivered to their home, including Daryl and Chow. Don't worry. But we just wanted to say that we are not quite sure, given the COVID situation and everything. And it would be international shipping, of course, but we would be shipping it to you as soon as possible. Also, regarding certificates, so you would be receiving your certificate shortly within these 3-4 days. Okay, feel free to post your certificates, add it on LinkedIn and all. So like for around 6 weeks, that you can say it's like 1.5 month, we were together each and every weekend, and we taught you various different things of machine learning, some different domains. You got to see how CV works, how NLP works. So I think everyone was like enjoying these sessions, like according to me. And I hope that at least you have learned something from all these 12 sessions that we conducted over the like over these 6 weeks. So just I would be just saying that thank you so much for joining in, and we would be of course conducting much more sessions like on deep learning and all if you want. So you can also join in there. And also, if anyone want to share their experience about this 6 weeks machine learning boot camp, or they have some suggestions that they want to tell right now, so feel free to even unmute or type it in the chat box.
Just giving them the permissions to unmute. Nothing.
Probably they have. Okay, so I think it's in, yeah, so it's available for everyone. Okay.
Yes, from the starting itself, we are trying to focus. At least if you have learned about 40% of what we have taught, that's more than enough. You shouldn't be focusing on completely learning all the 100%. No one in the world can learn in the first try. If you have learned 40%, that's great. Okay, from the 6 weeks, from the continuous 6 weeks, you are coming daily and attending the lectures. You're being responsive in the chat box. Okay, so it means a lot to me. It means it's kindly established a kind of bonding. Last year also we have hosted the events like Sheetos and Sheehacks. We have been teaching the students for one and a half months. So similarly, we have taught you for 1.5 months. It was very nice with interacting with you all. Okay, so you will be getting the certificate shortly, as Athava told you. So it's a complete 6 weeks. Okay, so you can post what you have learned, the topics you have learned on the under the bootcamp, and the projects if you have some screenshot while doing the projects and some projects, and just post in on the LinkedIn or Twitter stuffs. And don't forget to tag Athava.
So just show off whatever you have learned and create some cool projects. Let the world see that, yeah, you are like somewhat familiar with machine learning and what happens in NLP and computer vision. And of course, like this was not the only session. We have much more sessions planned in the future. In fact, we are going to organize some hackathons in this upcoming like 2-3 months. from IEEE CIS. So in fact, stay tuned for that. Do participate in those